The dynamic aperture function is a great way for a sonographer to narrow the beam at greater depths or various depths to improve your angular resolution, transverse resolution, and your azimuthal resolution by simply narrowing the beam, and that's key. These are all the same names or synonyms of lateral resolution. Anytime you hear those names, you need to automatically think lateral resolution for your boards because a lot of times when they ask questions, they're not going to say lateral resolution. They're going to say, how do you improve angular resolution? Or they'll say, how do you improve transverse resolution or azimuthal resolution? Get those names locked in with lateral resolution and you will do a lot better on the test. What happens in dynamic aperture is that as the focal length increases, the aperture will increase. In this diagram, you can see that there are a number of red rectangles. Each of these represent a crystal. What happens is the aperture increases as the signals from the increasing depths are increased to maintain a constant focus. So it'll change the focal depth based on the number of crystals being used. In this diagram, the outer crystals are shut off, thus resembling a smaller crystal compared to this one when they're all combined, which will shorten the near field length or the focal depth. Then when we go to this diagram here, the second to last crystals are shut off, thus making the crystal resemble an even smaller crystal, decreasing the focal depth and the near field zone, bringing the focal point to this area. Then when we go to this diagram here, we only have 3 crystals remaining with the 3 outer crystals shut off, making the combined crystals resemble an even smaller crystal, thus decreasing your focal length and bringing the focus or the focal point up to this area. In the beginning, we started with the focus in the far field because all the crystals were firing, resembling one large crystal with higher frequencies. Then we gradually shut out the crystals from the outside, thus bringing the focal point closer to the near field by making the remaining crystals resemble a smaller crystal with lower frequencies. And this is how you improve lateral resolution by making the beam width more narrow at various depths. With regards to dynamic frequency, you're going to have the highest frequencies or the widest bandwidth coming from the superficial region and the lowest frequencies coming from the Fraunhofer or the deeper regions. For example, if you're using a 6 MHz transducer, you'll have frequencies ranging from 7 to 8 in the superficial region, as well as frequencies ranging from 3 to 5 in the deeper regions. That means you'll have frequencies right here in the middle area ranging around 6 MHz and frequencies ranging from 3 to 5 in the far field. But this is how you increase lateral resolution with dynamic frequency, is because you can use higher frequencies for the near field. So in summary, what narrows the beam? Large diameter crystals, dynamic aperture. When you increase the operating frequency, you're increasing the resonation, the resonance, and the resonant. Also a thin half-value layer. But don't confuse resonation with insonation.
Which is related to this diagram? A. Dynamic aperture, B. Apodization, C. Dynamic frequency, or D. Pulse inversion? The answer is A. Dynamic aperture. Which does not happen when the image on top changes to the image on the bottom? A. Focal depth decreases, B. Far field angular resolution increases, C. Frequency increases, or D. The far field divergence decreases. So what happens when this top image changes to this bottom image? The correct answer is A. Focal depth does not decrease. This diagram represents dynamic aperture. The function of a dynamic aperture is to essentially move in and out electronically between a small crystal and a large crystal. Now, when you have a small crystal, that means you're using a lower frequency, your focal depth decreases, and your far field diverges more dramatically, thus decreasing your lateral resolution. When you use a large crystal, your focal depth increases, thus causing your far field to diverge less. This will increase your lateral resolution. Instead of switching out small and large crystals into a transducer, we use a dynamic aperture. By the way, aperture is also another fancy word for ceramic, element, active element, and PCT crystal. When you use the dynamic aperture function, this will cut off the voltage to the outside crystals, making it essentially a smaller crystal. So when we go back to this previous diagram, this essentially is a large crystal. Even though there's multiple little crystals here, you treat this as a large crystal. Each one of these teardrop-looking structures is a voltage coming down from the wire to excite these PCT crystals. Each crystal has its own cable with its own line of electricity. When we turn on dynamic aperture, we are cutting off the voltage to this crystal and this crystal, making it look like this. As you can see, there's no voltage. So this crystal and this crystal is turned off. Then these crystals are turned off, followed by these crystals. So in this diagram here, we're only using 3 crystals. This right here is a small crystal compared to this one. When we use less crystals on the outside and make it a smaller crystal, essentially, this is using a lower frequency. This will decrease your focal depth, and this will make your far field diverge more dramatically. And this will decrease your lateral resolution. When we increase the number of crystals on the outside, this will increase our frequency, this will increase our focal depth, and this will decrease our divergence in the far field, thus increasing lateral resolution. This is a great way to switch between a small crystal and a large crystal without manually switching in and out the crystals. So back to this question, which does not happen when the image on top changes to the image on the bottom. This top image represents a small crystal, and this bottom image represents essentially a larger crystal compared to this one. What will happen? Well, your frequency will increase. Back to the options here, when we change from a small crystal to a large crystal, we are essentially making the far field divergence decrease, thus increasing our lateral resolution in the far field. Our frequency increases. This will increase our angular resolution, our lateral resolution, our transverse resolution, and our azimuthal resolution. But our focal depth will not decrease because we're using a larger crystal. So actually our focal depth will increase. So this is the correct answer, meaning that this will not happen when this changes from this image to this image.